Oh, hello, chemistry folks. Ooh, boy. I gotta fix my hair here. I should probably look in the mirror once in a while. Ugh. Oh well. You get what you pay for, right? Ooh, that shirt looks really cool. I've never really seen this shirt on me. Jocelyn made this for me. Thanks, Jocelyn, by the way. Okay, chemistry. We are still in solutions. Now what we're going to do is we're going to go back to chemical reactions. Remember we called that stoichiometry. Where's my picture? Right here. Remember this thing? Well, when we had this last time, these little things weren't down there. This is another way we have to get in and out of Moleville now. So remember, we had, if we were given grams or needed grams, we could go to the periodic table. Right? If we had volume of a gas, we could use that PV equals nRT. Now, if we have a volume of and a concentration of a solution, we can use that molarity equation. And this is how it's usually written. Molarity is moles over volume, but usually we'll use moles equals molarity times volume. So that's another way in and out of Moleville. So I would recommend you print this thing. You should have it around, hopefully. You might need to add this stuff. I don't know if that was there or not. I don't think it was. So you might need to add that or print out another one or something. But I'd recommend you using this. It's handy to have. If we were still in class, I'd have a sheet protector for you. And that way you can write on it. Anyway, this will be your friend. One other thing I wanted to look at before we get going here. Some of you are getting kind of lazy on me here. Remember the rule is that you have to write down the units with the numbers. Right? And that's very important to do. And I have an example of that. And I think this was Daniel Corona, so I'm going to pick on Daniel here, but he's okay. He can handle being publicly humiliated, I'm sure. So here was Daniel's. This was that problem where you had to figure out the dose of lithium carbonate to get a certain amount of lithium. Kind of a tricky problem. And this is what Daniel ended up with. And notice he didn't put units there. Right? And it turns out this equation is wrong. And if he put units down, he would have seen that. Okay, so this is 0.2 molar, which is moles per liter. And that 0.014 is moles. And then 2.014 is 14.3. And he thought he got liters. So you can see over here he's got 14,000 milliliters. So he thought this was liters. But look at the units. The moles cancel. And you're not left with liters. You're left with 1 over liters. And that's not the unit you want, Daniel. That the unit's not the one. So that didn't work. There's another issue this points out too. Is when you're finished, you got to check your answer and see if it makes sense. All right. Now remember, this was a dose of a medicine. 14 liters. That's like 4 gallons. Almost not quite 4 gallons. So picture your nurse coming in here. Yo, patient, time for your medicine. Drink up. Yeah, a 4-gallon dose of medicine. Nah, it's not going to fly. So you want to make sure and check your answers. Okay. Oh, there's another one of these I can do. And this was actually Graham, so it's okay to publicly humiliate Graham. He's got the highest grade in the class, so just to show you that everybody does it sometimes. This was that problem where you needed 1.5 liters of 2 molar HCl, but you don't have 2 molar. You only have 8 molar. So what you can do is you can dilute down that 8 molar, add water to it, well, whatever, dilute it down. And then eventually you'll get 2 molar. But the question is, how much of this 8 molar do you need? Well, here's Graham's answer, 6 liters. Really, Graham? You only need 1.5 liters. So how are you going to dilute down 6 liters to get 1.5 liters? That doesn't work. So that would be a sign that that answer not going to fly. So anyway, make sure your answer makes sense. As usual, there's a worksheet that goes with these. You're going to want to print out. If you don't have a printer, just, I don't know, do them on paper, but don't try to do them on the computer. That does not work. Right? It's just too much going on, too much to format and stuff. This first one, this is 1A. we're only going to do one of these. You're professionals at this by now, so don't need to do any more. What volume of hydrogen gas would be produced when zinc reacts with hydrochloric acid? You're going to want to, again, use this thing, and this is where the sheet protector comes in handy. It asks what volume of hydrogen gas, so we're ending here, volume of gas, will be produced when zinc reacts with 2 liters of 12 molar hydrochloric acid. So we're starting over here. We've got this acid, and we know the volume and concentration. So we've got to end there. So we've got to go to, first thing we're going to do is go to moleville. Okay, and this is, we're going to call this step 2. And in order to go to moleville, we're going to use this thing, moles, that's step 2. Right? And then we got to change from moles of HCl to moles of H2, and that's going to be step 3. And we're just going to use the mole ratio. These little numbers, A, B, and C, the lowercase a, b, and c, those are the coefficients, so we're just going to use the mole ratio. And then now we're ready to leave moleville, and we need the volume of gas. Now we're going to use this guy, this PV equals nRT, that'll be step 4. And in this problem, we're not going to use the periodic table at all, because we don't need to worry about grams. That's the nice thing about having this. So I would really recommend you use this. So now, as is the case with all these, there's a chemical reaction. Let me get a swig of water here. There's a chemical reaction. And in order to get the chemical reaction, you got to balance the chemical reaction. But in order to get the chemical reaction, you have to get the formulas right. In order to get the formulas right, you got to get the ions right. How many times have you heard this? Been doing this since December. You should be professionals at this. But you got to pay attention. That last worksheet, some of you got tripped up on magnesium bromide. You wrote down MgBr. Well, that's not the formula for magnesium bromide. Okay, you got to get the formula right. So pay attention to the ions. So what volume of hydrogen gas would be produced? So we're going to produce hydrogen gas, right? When zinc and hydrochloric acid react, okay? Now, obviously, there's something missing here. There must be zinc and chlorine are going to hook up. But remember, zinc is 2 plus and chlorine is 1 minus. You still have that ion table that you can use. And by the way, this HCl, if you weren't sure what hydrochloric acid is, that's on that ion table too, if you don't want to look it up. And so the formula is zinc chloride is Cl2. So we need 2 chlorine here, 2 hydrogen, 1 zinc, and we're balanced. So step 1 is good. Now, step 1. Step 2. Oh, another thing that might be handy to do is underneath here, write down what you need and where you're going and stuff. Like, we have this, we have 2 liters of this, and it's 12 molar. Over here, this is what we're trying to find. We're trying to find the volume of this, but in order to find the volume, in this situation, we have to find the moles first, right? And then the temperature is 100 degrees C, but that's 373 Kelvin. Remember the 273, you got to do that. And then we're at 2 atmospheres of pressure, right? Now, the zinc chloride, we don't care about that. And the zinc, we don't care about that. It said excess zinc, and this has nothing to do with it. Well, it mattered in that we needed the balanced reaction, right? That's how we got like this coefficient 2 for the HCl. But now, at this point, the amount of zinc and zinc chloride doesn't matter, right? So that's a good thing to write down underneath there too. Step 2 is we need to figure out how many moles of this we had. Right, so right now we are here. So we need moles of HCl. And remember, moles is equal to molarity times volume. The molarity is 2. That's moles per liter. Remember, that's what molarity means. And we are at 12 moles per liter, sorry. 12 more, and we are at 2 liters. The liters cancel, then you'll check that out. We're left with 24 moles of HCl, okay? So that's step 2. So now we're here. Now we're going to stay in moleville, and we're just going to use the ratio from the reaction, and that's step 3. we've got this 24 moles of HCl. And for every 2 HCl, there's 1 H2. And so that leaves 12 moles of H2. Okay, so now we are here. We are now ready to leave Moleville, but we need to find out what volume of hydrogen we have. In order to find volume, we need this. And of course, volume is equal to nRT over P. Now, remember, N is number of moles, that's 12. This R, when we dealt with this R before, it was different values based on what pressure we were using, which was kind of a pain. It's pretty safe to say now we're done. We won't use any other pressures at this point in time of our careers. Right? So we're going to stick to atmospheres. So R is always going to be 0.0821. If you want the units, we're supposed to use the units, right? That would be what, liter, atmosphere, Kelvin, mole, right? I think. I hope. But that's kind of ugly. But it's always going to be 0.0821 now. We're not going to worry about those other numbers. So you throw those numbers in there, and you get the volume is 183.7 liters of hydrogen. Okay, piece of cake, right? Now 1B is the same thing. I think that's really all we're going to do. Well, okay. Let's actually look at 2B or A. Oh, let's look at 2B. One of the things about 2B, it says what mass of calcium phosphate is produced if 750 milliliters of 6 molar phosphoric acid completely reacts with excess calcium hydroxide. Okay, now, going back to this thing, there's two ways to think about this. You can think of this as the left side of the reaction and this the right side of the reaction. It's kind of how it's set up here. But you don't have to think about it that way. You could think about this is what you know and this is what you need to figure out. All right? Because the thing that's weird about both 2's, A and B, is that what you need to know and what you're given are both on the left side of the reaction. So technically what you're doing, like in this case, what mass of calcium phosphate, you're ending here. Uh-oh. Left the top off. Your ending here is produced from an acid. You're starting here, and so you're going from there and kind of going around here and out there, and this pen is dying. So you're starting here, going out there, kind of coming over here, and then going back out there again. All right. Now, that's the case because this is the left side of the reaction, and we don't care about anything on the right. Now, if you want to come out here, that's fine. If you want to do it like this, I mean, it doesn't matter. Don't let that hang you up. Again, just kind of don't worry about the fact that everything's on the left side. The other thing that's a tad tricky about this one, might be good to remind you of this. You've got this phosphoric acid, and again, these are on that ion table, and it's going to react with this calcium hydroxide. And remember, calcium is 2+, hydroxide is O-. I'll just put 1-. Phosphate is 3-, and hydrogen is 1+. Okay, so it's good to write those ions down because now this is a double replacement reaction. So what's going to be over here? Don't marry Fred and Barney, right? That's bad. Well, it's not that it's bad, okay? But remember, Fred and Barney in the show didn't get married, so we got to stick to the truth here in that regard. So the phosphate and the calcium are going to hook up, and then the hydrogen and the hydroxide are going to hook up. So the hydrogen and hydroxide, that's going to make water, of course, right? And the calcium and the phosphate, you'll need 3 calcium, 2 phosphate, right? One thing I wanted to mention too on this one, back at the number 1 here, don't forget about this right here. It was H2. Well, there was only one, it was H1 over here, but remember by itself it has to be H2. All right, so this is a diatomic molecule, those are on your ion table. Here, this is going to be H2O over here. It doesn't matter that he had 3 H's over here, or 4 H's, or whatever he had. The formula is going to be H2O over here, right? And don't forget to balance this. All right. And that's really all we got to do. Step number 3 and 4 are kind of the same. Like I said, you're professionals at this by now. You don't need my help anymore. I'm done. Nah. Don't forget, you can always shoot me an email if you need any help, because I don't go anywhere. I don't do anything. Just shoot me an email if you need help. We're going to have a test on this coming up after the AP test. I don't know when that is, though. So sometime we still have a test on this coming up. And I'm going to make one more video about there's some loose ends from these previous worksheets that I need to fill in. And so there'll be one more worksheet. Or one more video. No more worksheets. I don't think. So anyway, thanks a lot. Good seeing you. Have fun. Bye.